Alright, hi. We're going to be reading Norberg Rail Equipment Division, Norberg Model B, Dunrite, Gang Machine, Rexnord. This manual has got operation routine maintenance of the nautical rail maintenance of the machine. It covers the product information from the basic operation maintenance, specifically the safety information, and is provided by the use of the qualified personnel, supervisor, operator, strip of the equipment described herein. Measurement in the manual with both metric and the customary U.S. units equivalent. Both responsible for the operation maintenance of the equipment should be thoroughly studied with the manual before commencing operation maintenance. Procedure for the manual should be considered with a permanent part of the machine and should remain with the machine at all times. Additional copies of our manuals are available if there is part of the operation manual only, whose and whole operation of the parts nominal cost throughout the part sales department. The additional services information, parts application information is available with the Nordico product support resources in Milwaukee, Wisconsin, parts and sales in Oshawa, Ontario, Canada. Nordico. We ask that any of the comments, suggestions about this manual that's here from you. We are here to be service for you with our customers. Direct comments, inquiries. Nordico Technical Documentation Department, Nordico Incorporated, 245 West Forest Hill Avenue, Oak Creek, Wisconsin, 53154. Alright, hazmat material data. In effort for the provided information necessary for the employee safety training to meet the requirements of OSHA Hazmat Communication Standard 1910-1200, we use the OSHA Form 20 safety data sheets available to cover the material contained in this machine. If interested in receiving the information, please refer to the name, model, and serial number of the machine. Calling and writing of the directory inquires to Vice President of Operation Nordico Incorporated, 245 West Hill Avenue, Oak Creek, Wisconsin, 53154. Fax 414-766-2299 or 414-766-2288 for the phone. Alright, your Dunrite specification: engine is Briggs and Stratton's 326437 series, propulsion motors Charlie number 104 1004, engine operating speed 2,680 RPMs or 13 horsepower, gear type Bosch 9511234025, hydraulic motor vane type Denshin TMB00621R1, hydraulic valve through-way cross VS2 BKF2, spindle assembly Norberg 1700 RPMs, oil tank capacity 21.5 gallons, machine total length 108 inches, machine total width 84 inches, machine total height 54 inches, machine total weight 2,750 pounds. Alright, table of contents. Control: selector valve lever, the spin valve knob, the drill. Selector valve lever, the spindle valve knob, the drill feed handle, carriage post knobs. Operation instructions. Preparation for startup: hydraulic adjustment gauging procedure with the anchor, gauge plate for setting with the machine gauge shoe with the major adjustments, gauge shoe with the minor adjustments, adjusting gauge shoe can't, adjusting guide wheel position, adjusting guide wheel roller position, leveling the machine, adjusting the gauge, adjusting the spindle location, adjusting the drill depth, adjusting spindle height, the setting of the drill spindle with the spring tensions, adjusting the carriage stop rods, adjusting spindle drive V-belts, major belt adjustment and minor belt adjustment, lubrication instruction, engine and hydraulic system. Alright, general. The Dunrite gauging machine hold with the tie plate for the proper gauge E for the ties, drill for the accurately placement with the anchor stud of the gauging chute, run with the rail channel with the loose tie plates with the maintain each tie plate with a proper parallel alignment at a preset distance of the fixed rail. The two hydraulic driven spindles are mounted to a roller carriage assembly which moves forward and backward on the rails attached to the main frame with the anchor hole with a simultaneously drilled while under the carriage inertia continually being advanced. The Dunrite hydraulically self-propelled unit with the attaching truck frame support for the gauging chute with the traveling between the job sites and by towing. For towing. Figure 1 shows your selector valve lever. Control: for the operating control function for the performance consists of the following: selector valve lever. The two move with the forward direction, move with the selector valve lever toward the machine, travel the reverse of the machine. Move the selector lever opposite direction. When the lever is in the mid position, the machine is said to be in neutral and will not move in either direction. See figure 1. This is your selector valve lever. Alright, in figure 2 you see the spindle valve knob. Spindle valve knob, the spindle location, drill spindle rotations controlled with the spindle valve knob located with the lifting bail beneath the selector valve. When the valve knob is pulled out, the spindles rotate and pushing the knob in will stop rotation. Figure 2. Spindle valve knob. Figure 3 shows the carriage post knobs and the drill feed handle. The drill feed handle, the control of the lowering and the raising of the drill, spinning with the drill feed handle, with the offset with the tubular piece, with the extend outward of the operated portion. See figure 3 to lower the spindles and drill the hole handle towards with the hole with the drill with the required depth. The release handle, the spring will return with the drill spindle with the upward portion. It would be necessary to push the upward with the drill feed handle slightly after the hole is drilled to see if the free of the drill is due to the any binding with the holes. Carriage post knobs. Alright, this is the top of the, on the side. Alright, your carriage post knobs. Carriage post knobs provide the hand grip of the line with the drill spindle with the tie and plate hole of the grasping eve of the carriage post knobs depending on the direction of the travel. The spindle carriage can be moved forward with the backward one hand with the other hand with the free of the control with the drill handle. Figure 3 operating instruction. The preparation of the start with the complete with the following prior to starting with the Dunrite at each of the operations. Shifting, lubricate the machine according to the lubrication instructions at the end of this manual. Check the oil level between the hydraulic system and the engine and add oil if required. 3. Check the gasoline supply, replenish if necessary. 4. Refer to the engine manual instruction for the starting operating of the machine. 5. Start the engine, allow the engine several minutes to warm up. 6. Check the propulsion travel in both directions. 7. Check the spindle direction of the rotation should be in clockwise. Handle adjustment. The check of the following adjusting hydraulic system proceeds as follows. The check of the pressure gauge with the quick of the disconnect located the relief valve on the shaft end of the pump. Relief the valve setting screw should be back out and ensure the low pressure setting with see figure 4. Disconnect one of the quick couplers to the spindle drive motor. Start the engine action with the spindle valve gauge, but it should be show less than 1500 psi starting on the relief valve adjustment. Alright. Screw slowly, alternate 1500 psi reached over the gauge. Figure 4 show the relief valve adjusting screw and the quick disconnect. Lock the relief valve adjusting screw, move the pressure gauge with the quick disconnect located with the relief valve with the cap end of the pump. Back off the relief valve adjusting screw until the 1100 psi is reached on the gauge, lock and adjusting screw. Gauge procedure. Disengage with the tie plate, drill with the tie with the anchor start with proceed its valve. Pull the spindle valve with the knob out with the start rotation. Pull the spindle carriage on the carriage rail frame with the most forward position. Add the Dunrite propel along with the track of the line with the drill with the proper set of the hole from the tie plate. When the drills are aligned properly, drill with the holes. As the holes being drilled with the Dunrite and kept with the moving forward with the spindle carriage remain stationary. 6. As soon as the holes are drilled with the operator with the drill of the and again move the spindle carriage to the foremost position with the readiness for the next time. Anchor gauge plates. Immediately found with the Dunrite are 2 men anchoring with the gauge plate. The first man insert the wooden plugs or studs in the drill holes. Second man drive the plugs and studs down into the point where the head is tight for the tie plate hole. The setting up of the machine, if the Dunrite has just been towed over the job site, the machine is set up with the operation as follows. Move the wheel frame lock pin, see figure 5. Figure 5 show the wheel frame lock pin. Also, to using lifting handle with the raised operator side of the Dunrite enough to allow the truck frame assembly to be rolled out from the under rolling carriage assembly, see figure 6. This figure 6 shows the lifting handle of the wheel frame locking pins and the truck frame assembly. Swinging the counterweight support with the arms of the receiver of the truck frame assembly, see figure 7. Place the truck frame assembly with the counterweight support system. Figure 7 shows the counterweight support system on the truck frame assembly. Gauge shoes with major adjustment with the rail should be chained with the machine with the just last operated gauging shoes should require adjusting whenever the major adjustment required depending on the rail base width. If the machine has been working on the track that has been railed with a base of less than 6 inches, new track has a rail base greater than 6 inches. A major adjustment is required. The same the true with the going for the rail base greater than 6 inches. The rail of the base smaller than 6 inches. To adjust the gauging shoe, compensate for the major change in width of the rail base. Proceed as follows. Remove all the gauging shoes, adjusting pin, but carefully not to loosen any of the ball bearings. See figure 8. Place the gauging place spacers between the outside of the gauging shoe side plate with the ball bearing and the rail. If the rail base is wider than 6 inches, plate for the gauging shoe plate with the space of the outside bar with the inside gauging shoe side of the plate. If the rail base is under 6 inches, plate for the gauge shoe on adjusting pins. 4. Finally, set with the gauging shoe with the following of the instruction: the gauge shoe with the minor adjustments. Or this show of the wheels base and the wheel when base of the rails is 6 inches or less. The gauging shoe adjusting pin, the gauge shoe and plate spacer. This show when the base is over the rail of the gauge over 6 inches, the gauging shoe and adjusting pin, the gauging shoe spacer is moved. Gaging shoe with a minor adjustment, but to make the final adjustment of the gaging shoe, either the take of the major adjustment, the compensates the minor change of the rail width of the valves, move the adjusting nut locking bar, will remove the two attached adding socket head with the cap screw. See figure 9. The width of the gaging shoe should be 1/16 inch less than distance between the shoulder of the tie plates to be used to narrow the gaging shoe with the turn of the gaging shoe, adjusting the nuts with the right clockwise. This figure 9 shows the gaging shoe adjusting nuts, socket head cap screw with adjusting locking bar. Weighing the gaging shoe width, turning all the gaging shoe nuts to the left of the counterclockwise as gaging shoe width with adjusted. Check the center with the two gaging shoe size plates to maintain parallel to each other. The gauge should be made as near end of the gaging shoe possible at the end of the staggered portions. 3. Replay for the adjusting nut lock washer and attaching the side plate with the two socket head cap screws. Surface the gaging shoe can. The bearing and the gaging shoe assembly make for the full contact surface of the tie plate with the gaging shoe assembly that may have been adjusted to match for the can and the tie plate as follows. Look for loosening the 4 bolts at any of the gaging shoe assembly. See figure 10. Tighten the gaging shoe assembly until the both of the rows of the bolts rest on the surface of the correctly placed on the tie plates. Retighten the 4 bolts on each of the gaging shoe assembly. Figure 10 shows the adjusting bolts for the gaging of the shoe can. Adjusting the gaging with the wheel position. If the side of the rail with its chain with the gaging wheel with the required adjusting file. Set the gauge assembly with approximately with the correct position to get the desired gauge. Check the determine with the contact between the head of the rail and of the gaging wheel near the center of the bevel the surface of the gaging wheel. See figure 11. If the point of contact is off from the center, remove the axle cap and clamp screw for each side of the gaging wheel. Remove the axle clamps and see figure 11. With the gaging wheel assembled, remove and take the spacers off the axle one side of the gaging wheel. Place them on the outside, holding the back gaging wheel in place with the wheel support the brackets next to the rail. Check to determine whether the edge of the rail is in line with the center of the beveled surface of the gaging wheel. Interchange the additional spacers if required. 6. Install the axle clamps with the attaching socket head cap screws. Adjusting the guide roller positions. Different side of the rails will affect the position of the guide roller on the rail. The guide roller should contact the head of the rail about 5/8 inches below the top of the head, adjusting the vertical horizontal position of the guide rail roller of the following. Back off the guide roller bar, adjusting screw, see figure 11. Remove the guide bar roller pivot pin. Remove the guide roller bar assembly. Thread the eye bolt in or out with the roller bar, whichever is necessary to give it the desired height. Install the roller bar assembly. Insert the roller pin through the eye bolt and through the guide roller bracket. See figure 12. Adjusting the roller bar adjusting screw for the new guide of the roller position. See figure 11. Figure 11 shows the propulsion drive motor, the axle clamp with the axle clamp screws. The point of the contact near the center of the flat surface of the gauge wheel. A point of the contact 5 inches below the top of the rail head and adjust the guide roller above the adjusting screw. Figure 12 shows the guide roller bar bushing and the guide pivot roller bar pivot pin. Leveling the machine Dunrite must be leveled, but is put in the operation. Make sure the machine is resting level on the track. Then loosen the lock nut of the set screw for the gaging bracket of the figure 13. Back of the set screw is only enough to allow the back bracket slides into its mount. Place the small screw cross lever never the center of the mainframe as either end of the machine. Use the gaging wheel adjusting screw. Watching the cross level adjusting the screw until the cross level indicates the machine is leveled and is necessary. Level both ends of the Dunrite. Tighten the set screws and lock side. Adjusting the gauge to adjust the machine for the proper gauge. Set the machine in the position and firmly seat with the rail properly. Proceed as follows. With a tape ruler, measure the correct distance from the base of the fixed rail outside of the gaging shoe, several tie plates in their proper gauge position. Adjust the machine and fit the plates. If using the taper rule setting with the gauge amount with the distance between the rail base outside of the gaging shoe is oversized and undersized should be recorded. This shows figure 13 show the gaging wheel adjusting screw and lock nut adjusting screw. Through with the end of the tape rule against the head of the rail turn with the roller bar adjusting screw in or out of the shifting gaging wheel with the desired the direction. See figure 14. The amount of the gaging wheel is moved. It should be equivalent to the distance recorded in step 2. The roll of the Dunrite back and forth. The recheck with the gaging setting when you pre-position tie plates. Adjust for the gauge. Adjusting the machine. Use the roller bar. Adjusting the screw until the gaging shoe. Touch of the outside shoulder with the correctly positioned tie plate. Roll the Dunrite back and forth. The recheck with the gauge setting. After setting the recheck gauge, recheck the machine level as instructed earlier. Make adjustments adjustments to level the machine if necessary. Note, having set the gauge correctly, but do not change the gauge level adjustment due to the might seem the apparently variation of the new set rail. They all allow traffic to firmly set with the rail before readjusting the gauge, even if the small particle of dirt and stone will tilt rail enough to give you the impression of the incorrect gauge. Be ensured that the gauge will be seated rail before the adjusting was done right. Or adjusting the spindle with the location of the drill. Spindle with the drill holes in one of each side of the rail. The spindles can be adjusted with the closing farther apart with the position of the drill holes directly diagonal opposite of each other. The change of the drill spindle location for the following. Still select the two drill adapters, two test twist drills, the sum of the drills and adapters. See figure 15. Install the adapter spindle slide with the drill adapter lock collar upward. Insert the adapter and spindle. Make sure that the tab shank is firmly in place. See figure 16. Slack off the drive belts. Move the idle arm, adjusting the chain. Loosen the 5 clamping bolts on one at each of the end of the clamp bar, one at each of the 2 spindle housing clamps, and one at each end the feed rod of the bracket clamp. See figure 17. Shift the spindles until the drill lines are divided with the tie plate holes. Note the shifting of the spindle location may require the fluid motor location to also be changed to the provided sufficient spindle drive belt tension. See spindle drive belt, V belts, and adjustment. Figure 14 show the roller bar adjusting screw, and figure 15 show the setting jig and the counterweight support arm. Figure 16 show the adapter locker collar and the drill adapter. Figure 17 shows the clamp bolt, spindle housing clamp, feed rod bracket, spindle housing clamps, clamp bar bolt. Alright, adjusting the drill depth. The depth of the hole that is to be drilled with the tie must be correspond with the length of the anchor side of the two. Adjust the proper depth of the hole with the following. Rest the end of the drills on the top of the tie depth of the drill hole with the distance of the top feed guide to the underside of the spindle thruster bracket. See figure 18. Loosen the socket edge cap screw with the feed of the rocket bracket with the move of the feed head rod guide with the up and down with the required hole depth. And 3. Retighten the cap screws. Adjusting spindle height. Change the rail height with the effective of the height of the spindle relationship to the tie with the spindle with the uppermost raised position. It should be sufficient to height to provide a minimum clearance above the ply plates. Adjust the height within the spindle will raise to do the following. Back off the spindle top rod and lock nut figure 19. Turn the spindle to stop rod adjusting to the desired height. Retighten the lock nut. Alright, this shows the depth of the drilling from there to there, the spindle thrust bracket, the feeding rod guide, and the feeding rod bracket clamp. Figure 18. Alright, set the drilling spring tension. Adjusting the spindle height with the effect of the tension for the feed by the handle of the spring. The spring tension for the drill handle should be adjusted to adequate drill spindle for the uppermost of the position with the handle relief to adjust the spring tension. Compensate the change of the spindle height as it proceeds as follows. The spindle spindle in the uppermost position. Increase the spring tension, taking up the chain length with decrease the spring tension because by slacking off of the chain length with the figure 19. If there's insufficient adjustment of the spring anchor chain with the feed handle, we'll have the reposition follows. Loosen the handle pivot clamp cap screw and increase the feed handle length with the extend beyond with the pivot clamp and increase the mechanical leverage multiplying the spring force acting with the spindle. Decrease the mechanical leverage and decrease the feed handle length of the extend beyond the pivot clamp after the proper adjustment tightening the clamp screws. See figure 19. Loosen the set screws half of the collar hand of the clamp at the position of the feed handle so that the hand collar will be in vertical position approximately 1/2 of the hole depth and it has been reached. Tighten the hand clamp cap screws. They show the drill feed handle, the spindle stop rod, the feed handle clamp, the handle pivot clamp, the feed handle spring anchor, the tension adjusting screw chain, the feed handle springs, the spindle stop rod, and the feed rod guide. Adjusting the carriage stop rods. The carriage stop rods should be placed in proper hole so they prevent spindle carriage from moving into the point with the drill spindle with the housing striking the carriage rail frame. Still have the maximum amount of travel possible. When the spindle location has been changed with the carriage stop rods, may require adjusting as follows. Release the spindle carriage from the flipping back of the carriage lock pin. See figure 20. Show the carriage rod and the carriage latch lap. The carriage maximum forward with the backward position spindle strike with the frame with the carriage contact stop with the rods either in both directions. Stop rod with the bolt must be relocated in step 3 and 4. Remove the cotter pin from the end of the rod. 4. Remove the outer holes in the carriage rail frame with a step that still prevents the spindle from hitting the frame. Figure 21 shows the spindle carriage on the bottom, the idle R tension chain, and the fluid mounting motor mounting bracket. Alright, your spindle dry belts. Excessive looseness of the spindle dry belts may cause the drills to sail with the belts to slip, maintain with the belts too tight, with the cause for the belts to heat and frayed, with the resulting rapid of the belt with the wear. Check the adjusting belt. The proper tightness proceed as follows. Major belt adjustment if the belt is too slack with insufficient chain length, with the adequately tighten the belt with the fluid motor right position as follows. Loosen the two bolts of the fastest fluid the motor mounting bracket with the spindle carriage. See figure 21. Shift the fluid motor of the mounting bracket away from the drill spindle to tighten the belts. If the fluid motor is being repositioned to compensate with the change of the spindle location, move the fluid motor in which the direction allows the spindle to be relocated with the excessive slack of the drive belts. Tighten the two bolts securely. Minor belt adjustment. Minor adjustments usually associated with the belt straps during the break in the period can adjust to increase the belt tension of the idle arm as follows. Lift the the arm tension chain free from the tension locking detent with the see figure 22. Pull the chain insert with the chain link in the detent will extend with the spring so that there is approximately 3/16 of an inch distance between the spring coils. Figure 21 show the idler arm tension chains. The lubrication instruction engine follow the instructions for the engine. Manufacturer, the type of the grade oil, frequency of the change, the level of the bolt for the crankcase and the air cleaner. Point for the be greased each 8 hours of shift. The C-note 1 carriage guide rollers, 4 fittings, 1 each for the roller, carriage roller bearings, 4 fittings, 1 each for bearing. V-bolt, belt idler, 1 fitting on the side of the idler. The position of the points to be greased each week. C-note 1. Gauge wheels, adjusting screw, truck wheel bearings, 4 fittings on each of the wheel bearing. Points to be greased each month. Truck wheel hubs, 1 each fitting in the truck wheel hubs. Points to be oiled each 8-hour shift. 2 all oil cups are to be filled with a 10W motor oil while the machine is operating. Hydraulic system. The hydraulic system uses the regular 10W motor oil, but the system should be kept well fed with the free of the dirt and moisture of the system. Should be drained yearly, drained or replaced with new oil added. Note 1. The grease fitting. If the grease fitting is to be served with the multiple purpose types, grease suitable for the anti-friction sleeve of the bearing application. Check with the local supply of recommendation. Proper lubrication. Grease settings should be wiped and cleaned before servicing. The servicing sleeve bearings inject sufficient quantity of lubricating force for the old grease until the new cleaning grease is visible. Note 2. Oil lubricating components. Engine oil should be applied to the oil lubricating component of the friction surface of the moving parts. Alright, your instruction for ordering repair parts of the part with the book completely identifies all the part components of the Norberg railway machine in 3 ways: by part name, by part number, the by part name, and the by appearance of the part list, and contained with the breakdown of the equipment, the major assembly, sub-assembly, detail part of the day, the identify partner and appearance for each of the part is indexed with an illustration assembly for which is part of the first column of the parts that contain with the items numbers, which serve for the cross-reference between the listed part of the same parts with illustrated indentation for the parts of the description column and indicate the relationship of the part assembly, which is a part with, for example, any part indented with the beneath the assembly is either a detail of the portion of assembly under which is identified with the under the non-NP or non-procurable set separately. The quantities are listed and determined as follows. The quantity is listed in the assembly indicates the number of the assembly used per machine with the exemption of the sub-assemblies which are treated as detail parts. The quantities listed in the detail parts indicate the number of these detail parts used per assembly. Prompt service information. The ordering parts allow for the following information: the machine serial number for the machine nameplate, exact quantity for the assembly, detail part with the desired. Identify these parts by the part number and the part name. Specified method of shipment is desired. Rush order. Shipment and repair parts are urgently needed. Make out separate order for the need for the parts forward. Rush order separately for any of the other order requesting separate shipment. The avoid detail is avoid reference and other materials and forward primarily for the ordering repair parts. Forward all repair parts to the following address: Order code P.O. Box 1562, Milwaukee 53201. Fax 4141 4181 481-3199, 411-769-4607 or 4608. This has been a reading of the Nordico Model B Dunrite Gaging machine.